Each dock day will see a different variety of activity for the Starliner duo. On Monday, for example, Willmore and Williams will continue unloading cargo they brought to the station and will transfer some used emergency equipment from station to Starliner for the trip back to Earth. They'll stow their launch and entry suits aboard the vehicle and conduct a debrief with NASA and Boeing officials about the rendezvous and docking phase of the mission. Once Starliner's batteries are charged through station power resources, Starliner will be configured for quiescent operations. So, with hatch closure in the offing and the countdown proceeding for a liftoff 1 hour, 11 minutes, and 40 seconds from now, we'll toss it back from the Space Station Flight Control Room to you folks down at the Cape.
If you're just joining us, welcome to the official broadcast of NASA's Boeing Crew Flight Test, or CFT. What you are seeing now is a live look from one of our helicopters here along the Space Coast, orbiting the Starliner spacecraft atop a ULA Atlas V rocket. Inside that Starliner spacecraft, two NASA astronauts, Commander Butch Willmore and Suni Williams, pilot.
Maybe I just didn't get it formally from you, but you're back at flight level.
Affirmative.
Roger.
At launch, Butch and Suni will make history as the first people to fly aboard Boeing's Starliner capsule. And liftoff is targeted for about an hour and 10 minutes from now at 12:25 and 40 seconds p.m. Eastern Time. And we are happily proceeding, marching towards that T0 after a busy hour. Mike, can you kind of recap for people the last hour of the launch countdown?
Well, in the last hour, we got to see some really great engineering and launch operations and teamwork happen. So the second stage of the Atlas launch vehicle, called Centaur, it is powered. Its fuels are liquid oxygen and liquid
hydrogen, and it's already has all the fuel in it, but since they're liquid, they're very cold and they kind of boil off. So we just add a little bit more on top, so we top it off.
1 hour, 10 minutes.
The two valves that were used for topping off lost insight for their control algorithms, so they couldn't see the sensors, and it was an upstream bus, so they changed the control algorithm and logic, and got back in business. So we are back on the launch timeline. The crew was informed. Everybody was talked to about it. Never in danger. Just a way to just having to relook at a different control system and sensors. So in the meantime, the pad team was held off from closing the hatch just in case they needed to get the crew out today.
RC, Channel 1.
And they're
RC,
closing the hatch now.
Verify range ready for FTS open loop test.
Verified.
FTS LC.
This FTS?
Start final open loop FTS test.
Roger.
And FTS stands for Flight Termination System, in case the rocket were to go off course. Of course, by that time, the Starliner, if the FTS were needed, the Starliner would fly out of the way. And but that's just a normal test right now. And you can see they're closing the hatch. We're getting ready to launch in 1 hour and 8 minutes. Very exciting.
Yes, very exciting. You know, teams are periodically briefed on the weather for today's launch. Let's check back in with Daryl Nail over at Hangar AE with the latest. Daryl?
Thank you very much, Dee. And here at Hangar AE with the team, monitoring both the launch operation as well as the weather. We got a great weather report from our launch weather officer just a few minutes ago. Winds were the one watch item, and they were driven, as you look at the satellite map, by a high-pressure system off the coast of North Carolina that you can see there, that clearing area. You see how it's turning in a clockwise direction. That's what's bringing all of our onshore flow. That is what's driving these winds. You see the clouds going by overhead. So this image from College of DuPage, they've got our GOES 16 data streaming through, and it's a great representation. You can also see the ascent corridor as a result of that high-pressure system is also fairly clear all the way up the eastern seaboard. That's the track that Starliner will take. That's good as well. Only some moderate concerns for high sea states because of those winds. But overall, we are looking good in the corridor. We are 90%
LC
go.
Slick on Channel 1.
Go ahead.
Hatch closure is complete, and we're moving into hatch gross leak checks.
Roger.
All right, hatch closure is complete, a great milestone that we've reached in this operation to get to liftoff. And just to wrap up, 90% go here at the pad. We're good to go along the ascent corridor, and so for weather, we're looking fantastic for a June 1st day, and which is the first meteorological day of summer. Usually we have rain and thunderstorms this time of day. Unfortunately, we don't. There you see the graphic, 90% go. And everything look weather-wise.
Starliner Houston back with you, ready for pre-launch cabin leak check. You can prepare for cabin pressurization per your checklist. Configure the HIU Vox sensitivity knobs to maximum.
Teamwork.
And as we look at the Starliner capsule from inside the white room, the blue team getting ready to make their exit, doing their final preparations before they leave. You can see them going through their list of procedures right there on the desk there. Also, that's a great call out. We want to hear that the capsule can be pressurized, and so they're doing that now. At this moment, I want to welcome into Hangar AE Deputy Program Manager Dana Hutcherson, who is here now with me. Thanks for taking the time to come over and talk to us. You're on console. You've been listening to the teams, both ULA and Boeing, as they prepare this rocket and spacecraft to go. It's been a little exciting over the last hour or so. Talk a little bit about that, what you observed from ULA team and your team in getting through the ground valve issue where they were able to do a redundant system. And they were able to get that stabilized, get back into flow.
Yeah, it's been an exciting last hour or so, I guess, on the count. It's really cool to see the teams reacting to any anomaly that's been popping up, and they've been able to work through it. They've ran tests offline to validate the procedures and been able to jump right back into it to be able to get us back into the flow and the process. So it's really neat to see how everyone is ready for this launch and on point and just getting everything together for this launch today.
I was particularly impressed in listening to the ULA team and how quickly they worked through the problem and how fast they were able to bring the flow back in after resolving that redundant data issue that they had. That was impressive. Let's go over to the Boeing team. Earlier in the count, they pressurized the thruster manifold that had the issue with the helium leak. How did that go?
They everything went nominal. We expected to see some leak, and it was about the same. All the other checks came out nominal as well. So I believe that we are all systems go in that front. Haven't seen any other issues that have alerted us or alarmed us as well. So we're happy that we've discussed that at length, and we've planned out our procedures and our process of how we would react to that. But so far, everything is looking good with the helium system as well.
You mentioned discussed at length. This team, your team, along with ULA and Boeing, have worked extremely hard in the weeks leading up to this. I've sat in on a few of the meetings. It is amazing to me the amount of detail, the amount of work that has been done in order to verify and make sure this is safe to fly. Talk a little bit about how hard the team was working.
Oh, the team is just all the teams. You remember we started off with working with the ULA, with the valve replacement. So that started our process from the time we scrubbed in early May. So from there, we've moved into the working with the spacecraft and the helium anomaly. The teams have been working night and day to resolve that, to make sure that we've stepped through every procedure, every process, and making sure that we're okay. It's been phenomenal to watch the team and to see the camaraderie across all the boards and listening to all the experts and making sure that we are good to go. We've had to pull in a lot of extra boards and actually had another flight readiness review as well to make sure that the whole agency at NASA and then Boeing and ULA, everyone is ready to go. Very awesome to see this teamwork and the seamless teamwork across the board.
That Delta FRR just a couple days ago that was held, and we had a press conference yesterday, and the team reported out that everything is moving forward. You know, you're talking about how hard the team worked. They deserved a little time off, so you guys took Memorial Day weekend to kind of recharge a little bit.
Yes, we did. We allowed some the folks to go and take a little bit of a break, have a barbecue if they needed to, and get a little bit of a recharge, as you said, to be able to get back into and have a clear mind and be able to get back into the procedures for this week.
Further proof that you are indeed a human being. These are human people that are working on all this. I just got to flash this really quick. This is Dana Hutcherson on a local community magazine in our city. And here she is with her husband, Jeremy, and her 2 dogs, her 2 labs. I sat down to my dining room table. My wife had this sitting on, and I said, well, look at this. This is the woman I'm interviewing today for the launch broadcast. Learned some interesting things about you, Dana. You like to, obviously travel and do fun water sports all around Florida. And it also says here that you're an introvert.
Yes, I am very much so an introvert, but you wouldn't know it, I guess, some days. Yeah. But yes, that was really a surprise to get to see that and have that opportunity. Being featured on Cocoa Beach Living.
Cocoa Beach's own Dana Hutcherson, Deputy Program Manager for CCP. Thank you so much for being here. We appreciate it.
Thank you.
And continued good luck on the team working towards launch.
Appreciate it.
Yep. All right, we'll send it back to you.
We have teams monitoring today's launch operations here in Florida as well as in Houston. In the room right next to Leroy, you have ULA's Dylan Rice and Boeing's Lauren Brennicke, who have been monitoring operations with the rocket and the spacecraft for the last 3 hours.
Yeah, Dia, we've actually been monitoring them close the hatch and start the pressurization process. As you've seen there on your screen, I want to give you a little bit of perspective on how this works, and it's kind of interesting what the astronauts will experience sitting in there. It's a lot like when you feel a pressure change when you're in an aircraft. So their ears will pop, and the whole process, doesn't take very long. It just takes a couple of minutes. But our team is checking about half a dozen valves and more than 60 seals. So things like windows and hatches and vestibules.
And they will let the spacecraft sit for about 10 minutes while they check. You could think of this as like inflating a balloon. When you start to inflate a balloon, you'd be able to tell pretty quickly if there was any kind of a leak where the air would be coming back out of it. So very similar process here, and that's what the team is going through. If you are just joining us, we are just under 1 hour till launch time. A couple of hours ago, our teams, the Boeing teams, were able to confirm that the leak rate remains acceptable. If you've been following along with us this week, you may have heard about the helium leak that we had, but we know now the leak rate remains acceptable. And in fact, our teams even said that it looks better than before. So all good news. And Dylan, Atlas really has been all over the solar system. Today's a little different because we have crew on board.
Well, that's right, Lauren. And so, we really are thrilled to have Butch and Suni on board, and thrilled to be a part of this program as we put Atlas back in service for human space flight. This, on the one hand, we have some really thoroughly established processes and procedures that we've used for missions to the sun, the moon, Mars, and we're using those today. But this countdown really is unlike anything we've done before, and so we're just absolutely thrilled to be a part of it. We remain in our final built-in hold now as we continue to prepare for liftoff, but there are still a few things ahead of us today. As you talked about, the blue team is on the pad while that leak check is going on. They're continuing their preps to clear out. Once we do get the area clear, we'll be preparing the vehicle's propulsion and hydraulic systems for launch. We'll also be getting some data and loading that into the flight computer that will
help Atlas and Centaur steer through the upper level winds as we pierce the atmosphere. You'll also be hearing some comm checks between the Chief Launch Conductor Doug Lebo and the Starliner crew and Houston as well. As we get all those things will take us closer and closer to our launch opportunity today, coming up at 12:25 and 40 seconds. And of course, the one big visual cue that you will get that we're moving right along will be a retraction of that big crew access arm. So that's going to be coming up here in just a little over 40 minutes, a little under 40 minutes, I should say. But yeah, the big crew access arm will retract, and
and at that point we'll be very close to launch.
And it's really important that the crew cleans everything up.
On channel 1.
Go FTS.
Operation 55, step 270, FTS open loop test is complete.
Roger.
All right, we just heard that leak check is complete. Again, we are just under 1 hour. We're about 56, 57 minutes right now away from launch. The cabin leak check is complete, and we are moving forward nominally. Feeling like a great day to go to space, Dylan.
I agree. Let's do it.
Megan, we will check back in with you in just a little bit. Back over to you guys.
Well said, Dylan. Let's do it. And actually, why don't we take the time now to take another look at the crew making history with this test flight. You see Commander Butch Willmore closest to the screen here, corner right. Now, Commander Butch Willmore, NASA astronaut and retired U.S. Navy captain, was raised in Mount Juliet, Tennessee, is married to Deanna Willmore, and they have 2 daughters. As a naval pilot, Butch racked up more than 8,000 flight hours and 663 carrier landings, all in tactical jet aircraft. He completed 4 operational deployments supporting missions like Operation Desert Storm. Before his selection to NASA, Willmore was on exchange to the Air Force as a flight test instructor at the Air Force Test Pilot School at Edwards Air Force Base in California. Butch is a veteran of 2 space flights as a pilot on Space Shuttle Atlantis in 2009, and then in 2014 he served as flight engineer for Expedition 41. And so far, Willmore has spent 178 days in space and performed 4 spacewalks. This flight test will be his 3rd mission to the ISS.
And Suni Williams, CFT's pilot and a retired U.S. Navy captain. NASA selected her as an astronaut in 1998, just 2 years before Butch. This will be Suni's 3rd mission to space, making her the first woman on a test flight of an orbital spacecraft. Her first trip to the ISS launched in 2006. She served as flight engineer for Expeditions 14-15.
She then returned to the orbiting lab in 2012 and was commander of Expedition 33. Suni has more than 50 hours of spacewalk time, the 2nd most cumulative time by a female astronaut. So far, she has spent 322 days in space. Before NASA, Suni was a former naval test pilot and instructor, logging more than 3,000 flight hours in more than 30 different aircraft. Williams grew up in Needham, Massachusetts, and is married to Michael Williams.
Starliner at Houston on 1. Good pressure. The side hatch is being configured now. Audible noises may be heard.
Standing by, thanks.
She enjoys hanging out with her dogs, working out, hiking, and camping, as well as working on cars and houses.
What do these 2 not do, Mike?
No, they are some of NASA's finest, and were chosen to fly on this mission so that we can get Starliner certified and fly more Starliners to the space station in the future.
How does it feel, seeing your friends who you've trained alongside with
so many years now? How does it feel to see them about 53 minutes to launch?
I am so proud of my friends. I've been working with Butch and Suni for, as like Butch likes to say, half a decade, 5 years or so, and we're as you can see today, and all the work as we are getting ready to launch today, how much Butch and Suni, as well as we appreciate the whole team that we're part of. And Butch and Suni have really expressed their gratitude to everyone and try to include the team as we all go forward on this mission. And so I'm super proud of them, and I'm a little envious, but I'm really happy for them to be this close to flight. 53 minutes to go.
You're not the only astronaut that says that. It's okay.
As the crew aboard Starliner prepares to launch to the space station, let's take a look at what's in store for them, for Suni and Butch, while on this mission.
The mission of the Commercial Crew Program is to provide transportation for astronauts to the International Space Station.
Multiple providers provide you redundancy. Redundancy is important, as we know. In our systems, we have redundant systems.
But actually, more importantly, it's providing the aerospace workforce the opportunity to test out new ideas, new technologies, and work them into spacecraft. Butch and I are the first two to fly the Starliner, so this flight will be a crew flight test, so there'll only be two on board. We're gonna fly it up to the space station, dock it, and test it all out, and then come back home.
Everything's new. The procedures are new. We have procedures now that we didn't have a year ago because we've learned as the process has gone forward.
We've had 2 test flights uncrewed previously, but this will be the first time we're putting people on it.
We're test pilots, and so we're going to be testing the spacecraft in all aspects of the flight, from launch, on orbit, all the way to entry and landing.
We're testing out the environmental control system, we're testing out the manual flying of the spacecraft. Then while we're docked to the space station, we have a bunch of tasks to make sure that the spacecraft can act as a lifeboat. And just in case anything bad goes on the International Space Station, the crew on board can come to the Starliner and make sure that they're okay.
This has a mode where we call it backup mode, which is your get home mode, if you will. We can, without any communication at all, we can still effect a return to Earth, do a deorbit burn, and hit the point where we're trying to land, even without our computers. You know, that old mantra, failure is not an option, because it's a very dynamic thing we do flying in space, and it's not very forgiving. And we know that, and that's why we have these multiple systems and multiple redundant capabilities, because human life is special, and we want to preserve it at all costs.
I think exploration is just in the human heart. Butch, he describes himself as the first thing he said as a kid was why. And I think that's in all of us. Maybe we don't verbalize it, but we all ask why. And that's what exploration is. It's that next step of why. So why not go back to the moon? Why not try to live on the moon? It seems like a natural stepping stone to the next thing, Mars, which just calls us. Like, why is that planet there? What is the future of that planet? What is the future of our planet? And to be able to take these next steps in exploration, we're going to start answering those questions.
We stand on the pinnacle. This is kind of where everything, integration, everything comes together, which is where Suni and I sit. And this is just a part of the ongoing process of growing and expounding our knowledge and our understanding of all things for the benefit of mankind.
I am Suni Williams, and I am ready to fly NASA's Boeing Crew Flight Test.
I'm Butch Willmore, and I am ready to fly NASA's Boeing Crew Flight Test.
And we are ready to see them fly as well. You know, we've been inviting our viewers, you guys, to reach out to us on social media and ask us any questions you might have about this historic flight test. And one that we've been seeing a lot is, you know, why are teams still launching while there is a helium leak on Starliner, on the Starliner spacecraft? Mike, can you address that?
No, that's a really good question, and we spent a whole week and a half getting ready to be able to answer that to ourselves and to Butch and Suni, saying, why is this okay, or how is this okay, or should we take the spacecraft back and replace it? Well, we looked at not just the data that we've seen, but also what could happen in the worst case, and then what could happen even worse than that. And at every point, because Starliner, you heard what Butch said on the overview there, was that Starliner has a lot of redundant systems. So even if we were to, if that leak were to get bigger, and it hasn't, but if it were to get bigger, it could get a lot bigger, and we'd still be okay. And even if it leaked out the entire bottle of helium for that manifold, we could still fly back and land safely in the desert in Southwest United States. So NASA looked at what the risks were, and working with the crew, and the crew office said, hey, this is not ideal. We don't like this. But this is a test flight, and we were able to manage this risk and accept this risk. And it's a really tiny leak. We will be okay. And if it isn't, here's what we do. And we spent a lot of time in the simulators and writing procedures just in case. Just like we saw a little bit earlier, United Launch Alliance, they had a small anomaly. They said, all right, here's our alternate procedures. Let's run through it. And they went through it methodically. We do the same thing on board. So we have everything ready just in case.
Yeah, and just for more context, you know, as you said, this is a very small leak. Starliner could handle 4 more leaks, or this one leak growing by 100 times its current size before needing to be managed in flight. And actually, other spacecraft like Shuttle have launched with similar helium leaks in the past. Also important to note, teams continue to watch and monitor this leak to make sure that it's not growing. And as we've said, it has not grown in the time that they've first detected this leak. So again, that's why the decision is being made to fly, and that's why we continue to march towards our instantaneous launch opportunity at 12:25 and 40 seconds Eastern Time. Meanwhile, inside Mission Control at Johnson Space Center in Houston, folks there are keeping a close eye on launch, continue to do so. Here's NASA's Brandy Dean and Boeing's Jim May.
Thanks, Megan, and welcome back to the Starliner Flight Control Room in Mission Control Houston, where the flight control team is continuing to follow along with all the activities going on in Florida now that we are 46 minutes away from today's launch. Once Starliner gets off the pad, Jim and I will be with you through Ascent, giving you play-by-play and expanding on the calls that you'll hear Capcom Joshua Kutrick making to Butch Willmore and Sonny Williams on board.
There are a number of major milestones you want to keep an eye out for during Starliner's climb to orbit. The first call that you'll hear from Starliner's crew is roll program, coming from Commander Willmore, indicating that Starliner is rolling into the right orientation for ascent and orbit operations. Then about 45 seconds into the flight, the crew and Starliner will reach max Q, which is the maximum dynamic pressure that they will experience during ascent, and that happens just before they reach Mach 1.
Then a minute and 35 seconds into flight, the solid rocket boosters that give Starliner its first major push into orbit will have used up all of their fuel. Starliner will hold on to them for a little more than a minute after that and then jettison the boosters before second stage takes over and take Starliner away the rest of the way.
Starliner will actually reach orbit around 11 minutes and 58 seconds into flight, at which at that point the Centaur main engine will cut off. Starliner and its crew will hold on to that stage for a couple minutes and then separate from it at around the 14-minute, 58-second mark. From there, Butch and Sonny will be free flying on orbit in Starliner.
During Ascent, you'll hear Kutrick mentioning a number of abort-related milestones as Starliner moves past them. Starliner can safely abort all the way up to orbit, including off the east coast, off the coast of Newfoundland, and off the coast of Ireland. Beyond that, it will be able to safely reach abort to orbit, just staying in space as an abort. And of course, we're hoping not to need any of those.
Request permission to begin white room closeout.
Slick. Roger, thanks, Slick. Blue team, perform toxic vapor and O2 checks when raising the environmental seal and configure white room for launch.
Roger.
And Slick, if you get a annulus purge disconnect time.
And once Starliner has made it to orbit, the last major milestone before the crew begins what we called orbit ops is called the orbit insertion or OI burn. That will move Starliner into an elliptical orbit as opposed to a more circular one.
Slick, we're calling it 1537 Zulu.
Roger.
Going from a circular orbit, which they get off of after separating from Atlas, into an elliptical orbit, and then from there, Starliner will be on its way to International Space Station.
Yeah, and it sounds like the teams that have been getting Butch and Sonny ready are just about done with their job and ready to move, or getting ready to move away from the white room. But before we go back to Florida, let's check in with Rob Navius and the International Space Station Flight Control Team. Rob?
Thanks, Brandy. Just inside 44 minutes until launch, and back here in the ISS Flight Control Room, flight controllers are keeping tabs on the countdown and monitoring the work on board in the aftermath of the docking of the unpiloted Progress resupply craft earlier today at 7:43 a.m. Eastern Time. Now, NASA astronauts Matt Dominic, Mike Barrett, Jeanette Epps, and Tracy Dyson, along with Station Commander Oleg Kononenko of Roscosmos and fellow cosmonauts Nikolai Chub and Alexander Grabenkin, will form the welcoming committee when Willmore and Williams arrive on board tomorrow. The dock timeline is elastic. That means that the number of days that Starliner could stay at the station could be pared down or expanded depending on any further launch delays
or undocking delays driven by weather conditions at the western U.S. landing sites for Starliner. One critical dock day for the Starliner crew.
Starliner Houston, cabin leak check complete. You can open the vent valve.
All right, great. That's in work. One critical dock day for the Starliner crew will come 2 days prior to their scheduled undocking, when they load the last of the cargo items to be returned to Earth in the vehicle, and will conduct onboard manual piloting proficiency that will enable them to stay sharp for their departure from the station and the deorbit and entry events that will follow. So here we are at the intersection of Cape Canaveral, Houston, and space. And aboard the station, two of the Expedition 71 crew members, Jeanette Epps and Tracy Dyson, recently took a moment to set the table for the arrival of Willmore and Williams at their orbital destination.
Hey, Suni and Butch, we can't wait for you guys to join us here on station. We'll be monitoring your every move on the journey, and we'll be waiting to open the hatch and welcome you to your home away from home.
Butch and Suni, we know you've waited a while to get your ride aboard Starliner, but we know it will have been worth every minute. So from all of us on the International Space Station, Godspeed, and we'll see you soon.
As we prepare in less than an hour to launch 2 astronauts to space during this test flight,
Let's check back in with NASA's Antonio Jaramillo, who spoke earlier today with NASA's top administrator about this mission.
It's always an honor to be joined by NASA leadership, and joining me today is NASA Administrator Bill Nelson. Administrator Nelson, can you tell us why it's so important for the space agency that we have another American space company launching from American soil?
You always want to have a backup position, and in this case, a second spacecraft. For example, when we go to the moon, we will have 2 landers. We will have a SpaceX lander, that's first, and then the Blue Origin lander. But this is a significant launch of a test of a brand new human-rated spacecraft, and it's only 6 in the history of NASA. There was Mercury, Gemini, Apollo, then the Space Shuttle, then Dragon, and now the Boeing Starliner launching for the first time with humans on board.
That's right. It's very historic, very important, and you touched on this. Why is it important in general that we do have multiple spacecraft available to send humans to space?
Because we want to explore. We are exploring in many different ways with humans as our astronauts. We go back to the moon, not just to go to the moon, but to get ready, to learn, to live, to create in order to go to Mars. But that's just one part of our space program. The science, research, the exploration of the heavens, the commercial program. We're going back to the moon later this year with a commercial lander with a NASA instrument that's going to dig to see if there is water on the South Pole. It's a whole combination of a bunch of things that are going on.
That's right. You briefly touched on that. I mean, there's already been a ton of exciting missions this year. What else can the public look forward to?
Well, in addition to those, remember the first A in NASA is aeronautics. And we're going to fly the needle-nose new supersonic. It goes faster than the speed of sound, and it's designed so that it will not make the sonic boom, so that it could fly faster than the speed of sound over populated areas. That's one. We got another aviation project to improve the fuel efficiency by 30% of a mid-range single-aisle transport aircraft like the Boeing 737.
That is fascinating. Administrator Nelson, thank you so much for joining us here today. We'll send it back over to you.
We interviewed the administrator earlier because he is currently at the ASOC with the launch team as we watch the crew access arm moving away from the Starliner spacecraft. Now, the plan is for Butch and Suni to be docked to the ISS for at least 8 days, and after they will return to Earth with a soft touchdown in the American Southwest. there, this is video and sound from inside Starliner during its return to Earth 2 years ago as part of the Orbital Flight Test 2 mission. Its heat shield reaches 3,000 degrees Fahrenheit during re-entry, and parachutes are then deployed and the heat shield discarded to expose Starliner's airbags. The original test pilot, Rosie the Rocketeer, you see there, collected data of what astronauts might experience during landing. Starliner is the first and only American orbital crew capsule to land on land.
This allows for quicker access to crew and cargo. It also makes turning the spacecraft around for future missions quicker. But, Mike, Starliner can also land in water, like we were talking about earlier.
Yes, Starliner is a very capable spacecraft. Of course, we want it to land on land for the reasons you said. I love those airbags. I can't wait to ask Butch and Suni how good those are. But in case of emergency, we can land on water.
And we have a central airbag, another one.
Seconds, excess burn duration, and we'll go north to triage 6 if necessary.
The crew was just calling in. They just got some data.
And those are all good ways Starliner gives feedback. One additional item for you. In the commander's folio, you'll recall you have your 2 tablets. You've got a serial number 12 and a serial number 13. They're both ready to go, but one thing for you. Serial number 12, we were looking at footage here. Its time is out of sync, so it's no issue for you till orbit. When you're on orbit, you'll want to get that tablet, serial number 12, back in sync with the time on your DUs. It's only going to influence where you see the red line and bold. So if you did have to use bold before that, go ahead and do it on 13. Otherwise, we'll just resync in flight, and we can help you with that when we get there.
All right, good words. We'll copy that. And if we have any questions when we get there, we'll give you a call. And I have confirmed that I can reach the tablet.
Houston copies.
That was Josh Kutrick giving some last-minute info to Butch and Suni about their tablets, as well as in case of emergency where to go left or right at the end of the slide wires. But yeah, Starliner could land on water. We'd rather not, but it has that capability, and it has a different airbag configuration for that.
Yeah, the flexibility is great.
We have just about a half hour left before launch. Let's check back in with NASA's Antonia Jaramillo, who's now with someone who's been a part of Starliner since the beginning. Tony?
Thank you, Dee. For those of us just joining, we are here at OSB 2, one of the viewing locations for this launch. And joining me is Chris Ferguson, former NASA astronaut and Boeing astronaut. Chris, you've been part of Starliner since the beginning. How does it feel to be here and now get to watch it take flight with astronauts on board?
Well, given it's such a darn gorgeous day, I'm really excited. Of course, this is the culmination of probably 12 years of, just watching and working and getting involved with the development. But it's very excited to see it all come together. It's a little breezy out here, but you can't beat the weather.
Absolutely. It is a gorgeous day. Now, Chris, if you could give a piece of advice to Butch and Suni and to all our astronauts flying on our commercial crew missions, what would it be?
Well, Butch and Suni are pretty darn experienced. They probably don't need my advice. But what I would say, on a very first ascent of a vehicle and a re-entry, I would say take it all in, experience it. Think about what you're feeling, what you're experiencing, what's staging going to be like, what's it like when the parachutes come out, because these are questions that everyone's going to know when you get back, right? We want to know, did we build a vehicle that's comfortable to fly?
Absolutely. We can't wait to know. I mean, we're all taking it in here, too. Chris, it's our understanding that your fingerprints are all over the spacecraft, in particular the launch console and displays. What can Butch and Suni expect to see and experience aboard Starliner for their flight, and how does that compare to flying the space shuttle?
Yeah, I think the idea behind the design is to make sure that the crew always has reasonable awareness of what's going on. I remember with the space shuttle days, sometimes the displays were a little archaic. You had to really almost have a graduate degree to understand exactly what you were looking at. So the idea is to make it a lot more airplane-like, because the crews are very experienced pilots and aviators, and for the next generation of Starliner astronauts to come along, we want to make it very intuitive. So we've reduced the number of switches to the bare minimum. The shuttle had 1,000. We have 25 maybe. I don't know what the right number is, but it's a very streamlined. It's capable of being flown by a single person. So there's a lot of, I would say, upgrades that make it safer, and a lot more flexible than its predecessor, the Space Shuttle.
Definitely a very impressive spacecraft. You know, and Butch and Suni, they're going to also perform a few manual demonstrations aboard. You also were a part of this flight test in the beginning.
Can you talk to us a little bit about these manual demonstrations and just kind of the importance of why Boeing decided to have both a blend of autonomous and manual capabilities?
Yeah, there's always a sort of a contentious look, you know, between engineers and pilots on how do I control the spacecraft. The pilots always want the ultimate ability to take over in a situation when they need to. So the Starliner flies very much like the Space Shuttle and the Apollo and the other capsule vehicles with two different hand controllers where you can control all 6 degrees of freedom. You can maneuver it to an attitude if you needed to, say, charge your solar arrays or pick up a communication satellite. And they'll have the opportunity, of course, to check that out. And then there's also a deeper level of redundancy called backup mode, which is a means that the crew could manually fly the vehicle, even in the unlikely event that all the flight management computers fail. So there's a lot of redundancy, and it really is a true piloting vehicle, which is, I think, why the NASA customers really enjoy it so much.
I'm sure. Well, Chris, thank you so much for joining us. Megan D. Mike, back over to you.
All right, a quick check of the clock. We are 31 minutes and 40 seconds to liftoff of NASA's Boeing crew flight test. And right now, what you just saw on the screen there, you see Butch and Suni. They are patiently waiting their launch inside of Starliner's spacecraft there. And then also we did see the pad team who've been helping Butch and Suni into their spacecraft, as well as securing the spacecraft and closing the doors. They have since left the pad, right, Mike?
Absolutely. So only thing that's left is we have a rocket and a spacecraft and 2 human beings sitting on top getting ready for launch in 31 minutes.
Yeah, and so what we expect to hear coming up is just repeated communication checks with Capcom and Houston and with the crew. And also this is an opportunity, right, to discuss any anomalies or resolutions, but we haven't heard anything.
Yes, I think we hopefully got that out of our system earlier, and here we go.
Go ahead. Yes, sir. Per step 20, operation 60, blast in.
Hola, muy buenas tardes. Estamos comenzando la transmisión. Ya queda cerca de media hora para que comience el conteo regresivo y podamos ver cómo finalmente se comporta este lanzamiento. Ahí estamos viendo, bueno, el Atlas 5 en la plataforma de lanzamiento 41. Es la plataforma, una plataforma histórica donde se han lanzado una cantidad de vehículos espaciales tremenda. Es importante. Cada una de las plataformas de Cabo Cañaveral tiene diferente funcionalidad porque se han ido construyendo distintas formas, distintas plataformas, distintas necesidades que han ido cubriendo. No es lo mismo lanzar el transbordador espacial que lanzar, por ejemplo, este cohete. Tienen obviamente tamaños y características distintas. Así que muy bueno estar mirando esta transmisión en un lugar directamente histórico.
One temperature update complete.
Roger. Prop 1, initiate fuel fill sequence.
Roger.
Bueno, en este momento los astronautas están ya hace casi 2 horas en la nave espacial dentro de Starliner, de manera que, bueno, ya se han tomado todas las precauciones relativas a su seguridad, obviamente, y estarán, bueno, esperando, haciendo los últimos controles, chequeando, respondiendo al centro de control cómo se van manejando las cosas desde dentro de la nave, aunque específicamente ahora ya ellos no tienen mucho que hacer. Ya están amarrados literalmente a sus asientos y esperando que pase más o menos en unos 10 minutos el control de la nave y el control del lanzamiento a las computadoras de a bordo. Así que todo este viaje se conduce sin necesidad de que los pilotos tengan concretamente que pilotear la nave. La nave obviamente es autónoma, se maneja a través de los ordenadores y ellos no tienen mucho que hacer, aunque tienen que estar muy al tanto de las cosas que están ocurriendo dentro de la nave. O sea, no pueden estar, son la contraparte humana del equipo de control que está en el centro de control de vuelo.
This is likely the last you'll hear from us until liftoff, so we are going to send you back to the team in Florida to let Megan, Dee, and Mike see us through the rest of the countdown. We'll be back once Starliner is on its way. Go Starliner.
Brandy and Jim. Okay, let's take a closer look now at Starliner. The next generation crew capsule measures 16.5 feet tall with a diameter of 15 feet. That's about the size of a mid-size SUV. It was designed to carry up to 7 astronauts or a mix of crew and cargo for missions to the International Space Station.
Qué interesante que nos están mostrando aquí varias de las características de la Starliner. La Starliner aquí lo están poniendo en pies, pero la Starliner tiene, de altura tiene 5 metros. O sea, esto es una cápsula que tiene 5 metros de altura. Piensen en un espacio para vivir que tenga 5 metros de altura y 4 más o menos, 4 metros y medio de diámetro. Imaginen que están en esa cápsula, en ese espacio, y en ese espacio serán lanzados al espacio, literalmente. Ahí dentro tienen que tener todas las condiciones para poder respirar, para poder alimentarse, para poder tomar agua, hidratarse y demás, y además para poder cumplir con las necesidades fisiológicas básicas. Ahí es donde está el reto de crear un vehículo espacial, en cómo sostener la vida de las personas que están dentro de ese vehículo. Tienes que garantizar que no se pierda el oxígeno, tienes que garantizar que la presión sea más o menos ideal para un ser humano, que no sea demasiado agobiante. Y aquí nos está mostrando, esta es la parte más interesante de todo lo que hacen los astronautas. Obviamente, además de tener una preparación con los conocimientos de ingeniería, de física y de todas las cuestiones relativas a la ciencia del espacio que tienen que aprender, por supuesto tienen que volverse unos cuerpos muy preparados, muy físicamente preparados para poder llevar adelante y poder resistir todo lo que implica ir al espacio. En tanto, tienen que resistir fuerzas G muy altas. Un ser humano más o menos puede resistir hasta unas 9 fuerzas G sobre su cuerpo. Esto es una aceleración 9 veces mayor que la que que la que recibe uno normalmente estando en el planeta Tierra. Una presión sobre el cuerpo de esa magnitud puede ser mortal directamente. Y regularmente un vuelo como este, tanto en la salida, sobre todo en la reentrada, las fuerzas G pueden estar rondando los 3 o 4 fuerzas G. Piensen que si un humano puede resistir 9, 8, quizás 9, 4 es bastante, de todas formas. Se controla para que no sea tan terrible para quienes estén volando. Sobre todo se controla los cambios de aceleración, los cambios de velocidad, que son los que realmente pueden preocupar. El cambio de velocidad, o sea, no la velocidad en sí, es la que genera realmente peligro para la vida de los astronautas. Centro de control de ULA. ULA es United Launch Alliance. United Launch Alliance es una empresa que formaron conjuntamente Boeing y Lockheed Martin para poder sostener los lanzamientos, para seguir haciendo cohetes en conjunto y sostener los lanzamientos. Ambas empresas tienen una larga trayectoria en la exploración espacial. Son contratistas muy antiguos, de hace muchos años, que han trabajado para la NASA durante casi toda la carrera de la NASA. Desde Apolo, en los transbordadores espaciales, por supuesto en todos los proyectos Gemini y demás proyectos de transporte de la NASA. Y hace unos 20 años, casi 30 años, tuvieron que juntarse las dos empresas, Lockheed Martin y Boeing, y se creó United Launch Alliance. United Launch Alliance heredó los distintos vehículos de cada una de las empresas que manejaban las dos empresas y actualmente tenían como caballos de batalla, de carga, básicamente, los cohetes Atlas 5, que es este que están viendo hoy, y también el Delta 4 y el Delta Heavy. Ya estos dos cohetes, los cohetes de la versión Delta se retiraron. Actualmente el Atlas 5 es el que se sostiene, el que tienen aún en funcionamiento y además que está calificado para lanzar humanos al espacio. Así que bueno, este es el cohete que están utilizando. Boeing es quien es la constructora de Starliner y eso implica que les conviene usar sus cohetes, que son los cohetes de United Launch Alliance, ULA por sus siglas en inglés. Así que hoy están volando en la cima de un Atlas 5, la primera Starliner en llevar humanos al espacio. Esto es lo que están viendo hasta ahora. Aquí tienen a los dos primeros cosmonautas que viajarán, astronautas que viajarán en esta nave, Butch Willmore y Suni Williams. Suni Williams de piloto y de comandante de vuelo, Butch Willmore. Los dos tienen mucha experiencia en el espacio. Suni Williams tiene 7 caminatas espaciales, que es una de las más arduas tareas que tienes que cumplir en el espacio. O sea, tienes que salir de la nave, estar en un peligro potencial realmente grave. Cualquier cosa que te pase puede ser terminal para tu vida. Y tiene mucha experiencia Suni Williams, siendo una mujer, contando con que las mujeres empezaron a hacer todo este tipo de tareas bastante más tarde por las políticas que siguió la NASA siempre, que primero trabajó siempre con hombres. En eso los soviéticos se le adelantaron bastante. Y Suni Williams es una de las veteranas de los vuelos espaciales en Estados Unidos. Un astronauta con experiencia total, tanto caminatas espaciales, ha volado en los transbordadores espaciales, en Soyuz, y durante un buen tiempo ha tenido el récord de estadía más larga para los Estados Unidos en la estación espacial y en el espacio en general.
During the countdown, the individual teams, so think of the Atlas propulsion team and the Centaur propulsion team, are off working on separate nets as they perform their.
Quedan 18 minutos para el lanzamiento. Hasta ahora todo va funcionando perfectamente, en tanto no se ha anunciado no se ha retrasado en ningún momento el conteo regresivo y eso implica que apenas lleguen al go no go, pues estarán confirmándose las cosas para el lanzamiento, así que seguramente tenemos lanzamiento hoy.
And we'll also be listening to some of those side channels that aren't public on your TV screen right now. So we'll be listening for a few polls, one that's called the Starliner Readiness Poll for terminal count, and that is one of the shorter polls, and it will be coming from the Boeing Mission Control Center, or we call it the BMCC here in Florida.
The spacecraft launch conductor, Brian Gartner, will poll people in that room in charge of the propulsion system and power and many other subsystems. He will have 3 call-outs to him.
minus 17 minutes.
OSM, place SRB ignition S&A switch to the enable position.
SRB ignition enabled.
And verify FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed. Launch on time verified.
Roger.
And
LCP-1.
Go ahead.
AHP charging reestablished and at flight mass.
Roger.
So, Lauren, we're quickly coming to the end now of the launch vehicle pre-launch procedure, and we're just about 7 minutes away from our terminal count status check. But we heard a couple of call-outs there. That one of the range safety representatives activated the SRB ignition enable, so that allows us to fire the SRB ordnance circuits that ignite the SRBs at T0. Those circuits are not enabled till just as we heard, just a few moments ago.
minus 16 minutes.
And also another range safety system is the hold fire system. So there are remote switches at the Space Launch Delta 45 Morel Operations Center up the road. And if any of the range safety representatives see an issue, they can
press a button and stop our countdown remotely. So those switches have been enabled as well.
All right, you are taking a live look at Atlas V and Starliner stacked on top with astronauts Butch, Willmore, and Suni Williams inside, ready to go to space. We are just coming up on about 15 minutes from launch,
and we are going to send it over to NASA's Daryl now at Hangar AE. Daryl.
Thank you very much, Lauren. And you've heard the polls from ULA, also polling a go. The NASA operations manager, Richard Jones, checked with his team, gave them the go. As far as weather is concerned, you heard it mentioned on the nets, there was an L minus 30 weather brief.
We see your CMS Central. That's just to do with the internal power transition. No action.
Okay, no action. We got the 6 MDP low. It's back on now.
Looking.
No issue there. But again, the weather, 90% go. No concern. We're expected to be go for T0. We are go right now. Green across the board. We do have some high cirrus clouds, as you can see there up in the upper parts of the sky. And you can see the ground winds.
LC flight, channel 1 and air to ground 1 are now merged, going to air to ground 1. Roger.
LC flight, air to ground 1, ready for comm check with Starliner and channel 1.
Roger. Starliner, LC, comm check on channel 1.
LC, we got you loud and clear. Looks like we got all 6 fans failed a warning.
Butch Willmore.
And I copied your comm check, Starliner. In Capcom, did you catch
Aquí
that
tenemos el interior de la nave. La NASA está compartiendo ahora mismo este formato de transmisión en el que nos muestra el centro de control. Normalmente la cara de los controladores de vuelo parece bien preocupada y no es para menos. Están ahora mismo, como pueden ver, Butch, Willmore y Suni Williams dentro de la nave Starliner, listos para volar. En 13 minutos tienen que tomar la decisión, estar claros de que el vuelo va a funcionar completamente y ahora está todo el mundo concentrado en ese lanzamiento. Imaginen que tienes la responsabilidad de llevar a salvo hasta el espacio a 2 astronautas que están ahora mismo, como pueden ver en este plano, sobre una cantidad inmensa de combustible que va a salir, sí, de forma controlada al espacio, pero ese control está en manos de estos controladores de vuelo. Así que tienen que garantizarse la seguridad de los astronautas.
So the issue here is a problem with the primary suit fan operation. They got to have that suit fan to keep the air circulating inside their suits. With that having a warning, they've asked, Capcom has asked the astronauts to pop open their visors so they can get some fresh air, and they'll work it into a redundant mode, going into a redundant suit fan. So they continue to work that. As we get under T-minus 12 minutes and counting.
The Boeing team working an issue in real time right now.
LC flight channel 1. Go ahead. Yeah, the condition we're in an LCT condition with both suit fans down. We're trying to get these reactivated.
But we're going to proceed. Roger. So good to stow the crew access arm. I'm good. Roger.
All right, the team continuing to work the suit fan issue. Again, just to recap on weather, we're go. And now we're looking to take the next steps. So we'll send it back to Megan, Mike, and Dee.
Minus 11 minutes. As you just heard there, 11 minutes to liftoff.
Roger.
From only the 6-time NASA astronauts will launch on a new spacecraft designed for crew. I want to ask you really quick before we toss it over for that terminal count, the final moments of the countdown. How are you guys feeling?
Feeling great, excited, making sure teams work to troubleshoot the last little bit, and hopefully we'll see liftoff today.
I'm very excited for Butch and Suni, and as we like to say, go Atlas,
Bueno,
go
hasta ahora,
Centaur, go Starliner.
Go Butch and Suni.
Pensando en la comunicación que están teniendo, parece que todo iría bien, excepto porque hay un problema con los trajes, con el ventilador de uno de los trajes.
To start making its way back over.
Starliner, on our end, we brought suit fan Bravo back on. It looked good. We need both. We need to prove that A is also there, so we're commanding Alpha on and then off at this time. More to follow.
Bueno, parece que se ha arreglado el asunto con uno de los trajes espaciales que tenía un ventilador del traje que no estaba funcionando. Obviamente no puede pasar nada como esto y deben estar muy al tanto de cada uno de los elementos del traje, porque es muy importante que los trajes espaciales estén funcionando perfectos, porque sobre todo la presurización es muy necesaria para sostener la presión del astronauta, la cantidad de oxígeno que está fluyendo hacia él, y los cambios de presión que pudiera haber ante un eventual accidente tendrían que ser controlados y soportados por el traje espacial. Como ven, ya se está retirando el brazo de acceso a la nave espacial. Esto es un punto importantísimo. Bueno, en la playa. Esto es un punto importantísimo en el proceso de lanzamiento. Esto es un go, de verdad. Quedan 9 minutos, como ven acá abajo, para el lanzamiento. Así que bueno, síganos por aquí. Si se les ocurre alguna pregunta, déjenosla saber ahí en el chat y les vamos contestando lo que está pasando con este lanzamiento de Starliner. Estamos haciendo el seguimiento en vivo de este primer vuelo tripulado aquí en Técnicamente. Poquito a poco vamos a ir haciendo más de estos lanzamientos, más de estos seguimientos. Así que síganos por acá. Si te encuentras esta transmisión y no te has suscrito, suscríbete, que estamos intentando crecer poco a poco este canal y llevarlo a un muy buen lugar en cuanto a la cantidad de gente que tengamos en la comunidad de Técnicamente. Técnicamente, la idea de este canal es comunicar en castellano, en español, toda la información que tengamos a mano sobre la exploración espacial. Pasa que muchas veces es difícil para quienes no hablan inglés acceder a información de este tipo. Así que es importante que haya comunicadores y comunicadoras en español haciendo esta tarea con la exploración espacial. Se escuchan la risa del centro de control. Bueno, tengo una mosca aquí.
History as the first crew headed to the International Space Station on Boeing Starliner.
L-7 minutes.
Status check to proceed with terminal count.
Atlas systems, propulsion,
Go.
hydraulics,
Go.
pneumatics,
Go.
LO2,
Go.
water,
Go.
sensor systems, propulsion,
Go.
pneumatics.
Go. LO2. Go. LH2.
Go.
Has gas.
Estamos escuchando el go, no go.
Airborne. Go. Ground. Go. Facility. Go. RFFTS. Go.
Es un momento muy importante porque cada uno de los responsables está respondiendo si su área está en disposición para el vuelo.
Arm control. Go.
Go.
ECS. Go. Redline monitor. Go. Quality. Go.
Buenísimo.
Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go.
Ahí están preguntando a cada uno de los responsables de área
Flight director. Houston flight is go.
cuál es el estado de su equipo y equipamiento.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 16:25:40 Zulu.
Verified.
Ahí está. Parece que se lanza.
Starliner net is clear.
Thank you, LC. To all of you
Parece
sitting
que
on
se lanza en cualquier
console,
momento.
whether you're in Houston, BMCC, ASOC, Atlas, this is a great day to be proud of your nation. And all of you listening as well, whether you're at Banana Creek or the Causeway or the rooftop of LCC or the ASOC, and other places around our nation, like the Bay Area building and other places
Ahí
where
está la
you are
transmisión
viewing what's taking place.
con un discurso motivador.
For you, it's a great day to be proud of
Esta es una de las playas de la Florida que tienen, desde las que se puede ver el vuelo. Sería un placer tremendo estar ahí. Qué bueno. Nos quedan 5 minutos para el lanzamiento. Están volando hoy a bordo de la Starliner Suni Williams, una astronauta con muchísima experiencia en los vuelos espaciales, con muchísimo tiempo de estadía en la estación espacial y con muchísimos vuelos a su cargo. Además Butch Willmore, un astronauta también con muchísima experiencia. Acaba de ocurrir el go, no go a 4 minutos y medio del lanzamiento y parece que todo marcha nominal.
LC flight, Starliner configured to terminal count. Roger. All steps are complete prior to terminal count.
Ahí van.
And
Ya
with
está casi
that,
todo
we are
listo
ready to go
para
to space, Lauren.
que arranque
Hard not to be
este
emotional
vuelo
listening to those
espacial.
words from Butch. I'm sure we'll be
Es el primer
playing that
vuelo
speech back
espacial
for a long
que
time.
con tripulantes a bordo que se va a ejecutar desde la Starliner. Starliner es una nave espacial construida por Boeing. Vamos, ya no queda nada excepto el lanzamiento.
Launchpad ordnance circuits are now enabled.
Hold. Flight control received the CCLS, hold it. Approximately.
Bueno, nos pregunta Hernán Rodríguez, o nos afirma mejor, que parece muy antiguo a esta altura que deben hacer un go, no go. En realidad no. Este es un procedimiento muy antiguo, pero muy necesario porque sí, lo podrían poner, no sé, digital, pero también implica que todo el mundo se pone alerta. Son en el manejo de equipos que tienen tareas de este tipo. es bastante usual y bastante útil que se haga de esta manera. Así no hay riesgos de que alguno de los responsables de área no esté al tanto de alguna de las cosas que esté ocurriendo. O sea, para mí sí es importante, antiguo, pero importante. Así que Hernán, muchas gracias por tu comentario y sí, a mí me parece que sí es útil. Y de última tiene un valor histórico, el go, no go, ¿no? Es el momento en el que todo el mundo está esperando para saber si no ha pasado nada y si se te garantiza una... Quizás al menos en función del espectáculo está bueno que lo hagan. O sea, tiene su onda. Todo parece estar perfecto para el lanzamiento.
Has gas readings nominal. Roger. Vehicle electrical. VE channel 1. Avionics system stable. Roger. And LC can verify no indications of hazards. Flight LC. LC Starliner systems are stable. Roger. Starliner, last arm switch to off.
Last arm switch is off.
FCS in pre-flight mode, SS VAPs inactive, OCU safe, and EDS in test mode.
Roger. Arm control, deploy the crew access arm. Roger. Starliner, proceed with ordnance deactivation.
Passing one. Ordnance deconfigured. All off.
Roger.
LC.
And go ahead, ALC.
Countdown clock is reset, T-minus 4 minutes and holding.
Roger. Flight, verify CST 100 ordnance is safe. Verified. Okay, all stations, recycle systems back to T-minus 4 and holding configuration. Hold time occurred at T-minus 3 minutes 50 seconds. Report status at completion. And flight LC.
Bueno, hace un rato han dejado de mostrar el contador regresivo. Esto podría ser indicación de que algún problema podría haber. Esperemos que no sea así. Vamos a mantenernos chequeando. Voy a averiguar si está pasando algo por algún otro sitio. Bueno, pareciera que no, pero estemos al tanto. Estamos esperando que nada haya ocurrido y que nos reseten pronto y nos empiecen a mostrar el contador.
LC, PNE2.
Go ahead. Substep Echo CEC active.
Roger.
And substep Foxtrot sensor pneumatic system stable.
Roger.
LC Prop 1.
Go ahead.
Substep Charlie and substep Delta, Atlas propulsion and hydraulic system stable.
Roger.
LC ECS.
Go ahead.
Substep November ECS set point stable.
Roger.
LC, this flight control.
Go ahead.
Subset Kilo, flight control ready.
Roger.
Esto sí lo podemos ver con preocupación. Que esté volviendo el brazo implica que han cancelado el vuelo. O sea, no hay manera de que estén volviendo a poner el brazo de acceso y que no estén cancelando el vuelo. Bueno, parece estar relacionado con que no van a estar a tiempo para, o sea, no hubo tiempo para lanzar, no habrá tiempo para lanzar en la ventana de lanzamiento correcta. O sea, hay una...
If you're just joining us here at Cape Canaveral Space Force Station,
ahí nos están comunicando.
True access arm is deployed.
Roger.
We did have a automatic hold of our ground launch sequencer shortly after we began our terminal count for today's launch attempt. No indication yet as to what caused that hold of the automatic ground launch sequencer. The team is still evaluating data. In the meantime,
bueno, lo que están diciendo es que el secuenciador del tiempo del conteo del lanzamiento se detuvo. No tienen información sobre cuál fue la causa y eso implica que al haber sido una detención automática, no se tiene control sobre ella. Fue debido a los manejos automáticos del equipamiento y las computadoras a bordo. Por lo tanto, no se tiene control y al haber habido una parada se retrasó el tiempo de lanzamiento como para que estuviera dentro de la ventana precisa en la que se tiene que lanzar. O sea, para alcanzar la Estación Espacial Internacional hay que lanzar dentro de un tiempo específico cuando la estación está en una posición determinada sobre el planeta. Si no lanzas en ese tiempo tienes que esperar al otro día o a una órbita siguiente que te permita hacer las maniobras que tienes planificadas para poder llegar a la estación espacial. Y si se sale de ese tiempo, pues no se puede hacer el vuelo. O sea, puede ser que no haya ocurrido ningún problema que impida al cohete volar en otra ventana de lanzamiento en uno de estos días y se pueda lanzar sin regresar a las áreas de ensamblaje, pero parece que sí, que definitivamente hoy no hay vuelo.
Gentlemen. Yeah. Roger. Secure CST-100 prop system. Last valve to remain open.
Flight copies. Probably take us at least 5 minutes here.
Yeah, copy.
We're going to send it over to NASA's Daryl Nail over at Hangar AE for some continuing coverage of our current
FTS,
status.
LC.
Daryl?
Thanks, Dylan. And I'm listening to the NASA operations manager's loop.
Recycle status.
Recycle.
Roger. SYS, LC.
Yes, LC, GG30 is ready.
Roger.
Bueno, pues definitivamente no se lanza hoy, no se lanza. Boeing sigue dando muestras de no tener mucha suerte, vamos a decirlo así, para lanzar. Se han retrasado todos los lanzamientos de prueba de la Starliner, se han retrasado sin falta. O sea, o se han retrasado la fecha justa para el lanzamiento o directamente en la plataforma de lanzamiento los vuelos se han cancelado. Se canceló el primer vuelo, se canceló el segundo vuelo de prueba y este tercer vuelo de prueba, que ya sería el primero tripulado, se ha cancelado siempre que tuvo fecha y además se han atrasado todas las fechas que ha tenido porque se han cancelado, se ha hecho un hold de los lanzamientos. Así que bueno, otro tiempo más de espera. Vamos a ver vamos a revisar por aquí a ver qué anuncian, si están anunciando alguna fecha. No se tiene idea clara de qué ocurrió.
Sequencer, essentially the computer that launches.
Escuchemos ahí.
This is the computer that is in
Okay, all
charge.
personnel going to Operation 85. OSM, LC.
OSM.
Establish the BDA roadblocks and open the flight hazard area.
Roger.
And all personnel on Channel 1 will be starting an approximate 65-minute hold at this time for flight crew egress. All systems maintain T-4
And holding configuration.
The hold time is not relevant at this point. The fact is they're getting it into a state where they can go through
and get the crew out of the spacecraft. But I was mentioning the computer. This is the computer that when we go into terminal count, launches the rocket, brings a number of systems and a huge number of
operations all at a rapid pace. Something with the GLS, it's not understood at this time what it is, caused the GLS to throw an automatic holdout at T-minus 3 minutes and 50 seconds.
Arm control. Yeah, per step 40, can you give me that call out on the status of the crew access arm?
Crew access arm deployed and latched. Arm control is terminated, ready for personnel access.
Roger. And FELC?
Go ahead.
Start CAT TVM system monitoring.
Roger.
Bueno, ahora mismo están intentando
RLM on 1.
Disable RLM line items for crew egress per red line
armar
report.
toda la secuencia que implica sacar a los astronautas de la nave espacial. Hay que pensar que este cohete está completamente cargado de combustible. O sea, la tarea de sacar a los astronautas debe ser más o menos expedita, porque en el caso de una falla, de algún problema, estarían en uno de los peores lugares para estar en ese momento, que es sobre el cohete, en las operaciones de entrada y salida. Que ahí es donde más peligro hay realmente, porque una vez que ya se cerró la nave, que la nave está en disposición para el vuelo, si hubiera un accidente, si hubiera una explosión, si hubiera algún tipo de anomalía, la nave puede, por sí misma, puede eyectarse, salir volando, separarse del cohete, salir volando y poner a salvo a los astronautas. Todas las naves espaciales tienen una manera de... Bueno, no todas. El transportador espacial no tenía forma de salvar a los astronautas en esa circunstancia, en realidad. O sea, tenía que garantizarse que no iba a explotar ni en la plataforma y obviamente en vuelo tampoco. Alejandro Suárez pregunta qué pasó. Bueno, parece que no saben todavía. Una de las computadoras que controla el vuelo ya automáticamente, autónomamente, detuvo el conteo, detuvo el progreso de del lanzamiento, y eso provoca que esa demora implica que ya no podrían lanzar dentro de la ventana de lanzamiento que tenían para hoy. Por lo tanto, tienen que parar inevitablemente el vuelo. Aunque revisen y sepan qué pasó, ya no podrían lanzar hoy. Así que, cancelado por hoy.
The report out that we heard by the CGLS was that at the time of the scrub, when the hold was listed, it didn't appear to load into the proper configuration. ULA will work to try to understand the cause behind that. They don't know that at this time.
Ahí lo están diciendo, que ULA no tiene idea bien de qué ha pasado, de cuál fue la anomalía que provocó que la computadora de a bordo detuviera el proceso de vuelo, el proceso de lanzamiento.
Throughout this process. So we can see on the views here inside Hangar AE that they have the crew access arm back locked into the Starliner. You can see that on your screen there. essentially the team now working. Just to recap, if you're just joining us at 12:21 p.m. Eastern Time, T-minus 3 minutes and 50 seconds until liftoff. A hold was given by the ULA launch team, an automatic hold that was issued by the ground launch sequencer, the computer that takes over terminal count. The reason for that hold
Eso,
is
la
not known at this
computadora
time.
que lleva la responsabilidad de hacer todos los conteos finales para el lanzamiento, detuvo el proceso. Así que, habiéndose perdido la ventana de lanzamiento para hoy, cancelaron el vuelo. Scrub es la palabra que se usa en inglés.
Once it is safe enough that they get the crew of Butch Willmore and Suni Williams.
Están esperando que estén dadas todas las condiciones de seguridad para hacer la conexión del brazo de acceso con la nave y a partir de ahí intentar extraer a salvo a los astronautas Suni Williams y Butch Willmore. Y este es un momento bastante peligroso realmente. Todo este cohete está lleno de combustible. No se hace transferencia hacia el cohete o del cohete hacia los tanques. O sea, tampoco se vacía mientras estén los astronautas a bordo de la nave. Precisamente por eso, para evitar cualquier problema, cualquier fallo que haya, puede provocar una explosión gigantesca. Un cohete como el Atlas 5 puede tener unas 500 toneladas de combustible, involucrando tanto el combustible líquido como el combustible sólido que tienen los boosters que lo acompañan y que, bueno, que representan una de las mayores fuentes de fuerza y de impulso para el cohete.
Process to establish a stable configuration so that we can start pulling the crew off of the Starliner capsule. Still no update yet in terms of what caused the ground launch sequencer abort, but just like loading the crew, we establish a safe and stable configuration with the launch vehicle before we begin the egress process, and the configurations are very close to the same, actually. We'll be maintaining the propellant systems in a topping mode and not changing the state of the Atlas or Centaur as we go through the approximate 1 hour process of egressing Butch and Suni from the Starliner capsule. But teams are continuing to evaluate the data and look into the cause of the ground launch sequencer abort. In the meantime, we will start to see indications that the team is re-entering the pad. And in fact, the direction was just given to allow the blue team back into the pad. So we will start to see that activity now, and teams come back into the pad, back up the tower, and begin the process of opening up Starliner and egressing Butch and Suni.
Yeah, so that's a good sign there. You mentioned with the blue team coming back to the pad, they are the ones that will pull the crew out of Starliner. We heard that the pad area is cleared for them to come in. It's a good sign. Dylan, what's your time estimation on the team going through the rest of their procedures to make sure that the crew can go ahead and get up the elevator?
Actually, I think that we're there. So it's been just about 20 minutes since the hold was called, and in that 20 minutes time, we've established those configurations. In fact, we don't even let the pad team come back through the fence line until those safe and stable configurations have been established. So. Once the team will of course be standing by at the fallback area, and they were contacted via radio and told to proceed back to the gate, and they will proceed through the gate and right back up to the crew access tower and on up to level 12 where they can begin configuring the white room. So we are there at this point in terms of being ready to redeploy the environmental seal, which kind of encloses the Starliner door into the white room, and then we'll begin opening up Starliner so that we can egress Butch and Suni.
Yeah, we can see from this shot here that environmental seal is not on. Of course, this is the configuration right before you move the crew access arm either away or back to the capsule, so you can see the open air between.
Bueno, por ahí nos están contando cómo va el proceso de extracción de los astronautas. Si se fijan, estamos viendo que una de las razones aquí, un Automatic Hold on Ground Launch Sequencer, o sea, una parada automática de la secuencia de lanzamiento debido al sequencer, a esa computadora que controla toda la secuencia de lanzamiento. No va a haber aceleramiento y Alexis. Desgraciadamente, porque es un vuelo que se está esperando hace mucho tiempo. O sea, este vuelo presumiblemente debería ocurrir sobre el 2020 más o menos. O sea, en la primera intención la primera propuesta de Boeing, en 2014 Boeing anunciaba que iba a volar, por lo menos iba a tener la nave lista para volar en 2017. Esto no ocurrió. Finalmente Boeing terminó volando el 20 de diciembre de 2019, con la esperanza de hacer un tiempo después un vuelo tripulado. O sea, el primer vuelo, el OFT, Orbital Flight Test, habría sido de prueba sin tripulantes, y los tripulantes vendrían en un segundo vuelo una vez que este primer vuelo haya mostrado que la nave era capaz de ejecutar todo el proceso, tanto de lanzamiento como de maniobrabilidad en el espacio hasta llegar a la estación espacial, y también la capacidad de conectarse, acoplarse, y por supuesto que todos sus sistemas funcionaran. Si ese hubiese sido el caso del primer vuelo, bueno, se habría dado un segundo vuelo tripulado que, al ser el primero en diciembre de 2019, se suponía que no tomara más tiempo que, digamos, 2020, el 2020 más o menos. Pero esto no pasó. En 2019 no salió bien el vuelo, y el segundo vuelo de prueba sin tripulación terminó ocurriendo finalmente en 2023, o sea, 2 años después. El 20 de mayo de 2023. De 2022. Después anunciaron que en 2023 harían este vuelo de prueba tripulada, y no ocurrió tampoco. Se anunció finalmente este año para el 6 de mayo, y desde el 6 de mayo, o sea, hace casi un mes, se está esperando porque finalmente se den las condiciones para este vuelo de hoy, que tampoco ocurrió y aún no se sabe por qué. O sea, se sabe que la razón es esta, que la computadora de a bordo, bueno, no la computadora de a bordo, sino ya del sistema de lanzamiento del cohete, paró la secuencia de lanzamiento, pero no se sabe cuál es la razón. La razón concreta por la que se disparó este alto en la secuencia de lanzamiento.
It's a process that requires that team to do some manual work to lock in the crew access arm to the Starliner capsule. And so they will wait for those moments to arrive
we've got Lauren Brennicky on, our PAO with the Boeing team. Okay, we just heard a call that the blue team is entering the pad, and I can see them on the closed circuit television. They are in their van, as you can see there, the shot there, arriving back. This is the team that will head back up the launch tower.
En Twitter dice la página de Boeing Space que están precisamente en esta situación. No se sabe cuál fue la causa concreta de que se detuviera la secuencia de lanzamiento y que, bueno, ahora están concentrados en el proceso de extraer con seguridad a los astronautas de la nave. Ahí está llegando uno de los equipos que atiende y lleva adelante todo el proceso de lanzamiento, todo el proceso de ubicación de los astronautas dentro de la nave y, por supuesto, son los responsables de hacer esta operación una vez que los astronautas tengan que salir del vehículo porque haya una situación como esta, una cancelación del vuelo. Tenemos una foto por aquí del equipo que se encarga de hacer la extracción, de ayudar en el proceso de abordaje de los astronautas y también de hacer la extracción, obviamente. A ver si las encontramos.
Often the case in some of the different sim scenarios they put together.
And so they will go through this checklist that they know very well, where they will go through the everything that it takes to basically get the spacecraft back in the shape that it needs to be in
so that we can turn around and do this again and go for it again. Of course, we have launch windows tomorrow, as well as the 5th and the 6th. We don't yet know.
Pues qué lástima que no tengamos lanzamiento hoy. La verdad, estaba con muchas ganas. Esta es la primera transmisión en vivo técnicamente y esperamos, por supuesto, cuando nos den una nueva fecha para el lanzamiento final, una fecha en la que finalmente Boeing concrete un vuelo de su nave Starliner. Ya esto estaría demorando unos 7 años, estaría retrasado el lanzamiento unos 7 años y sería importante que ocurriera, no solo para la confianza de los posibles contratadores de los servicios de Boeing para ir al espacio, sino por supuesto de los astronautas que tengan que viajar en esta nave. Es improbable que a alguien le guste volar en un vehículo que constantemente está dando muestras de problemas. Aquí tenemos el equipo. Este equipo tiene que estar preparado para muchas contingencias. No son pocas las cuestiones que pueden ocurrir, los problemas y los desperfectos que podrían ocurrir y casi todos potencialmente letales. Están en la cercanía, están acompañadísimos por un cohete lleno de combustible. Unas 500 toneladas aproximadamente podría estar conteniendo de combustible este cohete. Es un cohete grande, un cohete muy capaz, muy responsable de muchas operaciones en el pasado, ya no de muchas en el futuro, porque es uno de los cohetes que se piensa retirar en algún momento. Pero es una bestia llena de combustible que de explotar no sería nada agradable estar ahí, en la zona. La manera de escapar es a través de unos deslizadores como estos que se usan para viajar a través de los bosques y lanzarse de una montaña hasta la base, a los que tendrían que tener acceso. O sea, por ejemplo, en este momento en el que están ascendiendo hasta el tope de la torre, están, la verdad, bastante indefensos los miembros del equipo de atención a los astronautas.
Coordinating with the Space Launch Delta 45, our Eastern Range partner, to let them know that we are intending to utilize that day, which actually has already been scheduled as a backup launch day. So we'll be coordinating that with their teams and all the support that we get from the SLD 45. And additionally, we'll be working to establish our systems on Launchpad 41 in a state that is ready for another launch attempt tomorrow. So even though we do still have some work to do this afternoon, which will include detanking Atlas and Centaur, at the end of the day, probably approximately 4 hours from now, we'll have the vehicle fully detanked, and we'll have the systems turned around and ready for another countdown opportunity tomorrow. So that could take a little bit longer if the anomaly team comes up with some troubleshooting steps that we need to run through, but have not heard anything like that just yet. For now, I think our team is still looking at data, but we're going to proceed as if we're going to make an attempt tomorrow until such time as we learn that wouldn't be possible. But for now, we are proceeding for a launch attempt tomorrow.
Yeah, that great point about the launch attempt is already there and available tomorrow if the NASA, ULA, and Boeing teams decide to take it. It's worth noting that T0 is already set for June 2nd, and it's 12:03
and roughly 07 seconds p.m. Eastern Time. Again, 12:03:05 p.m. Eastern Time as you're looking at the blue team configuring the crew access arm around the Starliner capsule, where inside astronauts Butch Willmore and Suni Williams are inside awaiting to be egressed.
Bueno, la próxima ventana de lanzamiento sería para mañana día 2 de junio. Podría ser que finalmente se ejecute el vuelo. Esto depende obviamente de que cuando revisen, hagan una revisión exhaustiva de lo que ha pasado hoy, no sea un problema mayor. Podría no serlo, pero hasta ahora no lo conocen. O sea, Boeing ahora mismo no tiene idea, o por lo menos no lo está comunicando, qué fue lo que pasó. ¿Cuál fue la razón para que el vuelo se detuviera? Fue una detención automática, así que hasta que no chequeen toda la información que les genere las computadoras que tuvieron la responsabilidad de hacer la detención, no se van a enterar mucho. También es que mientras se está trabajando en la extracción de los astronautas, no se ejecutan otras acciones en el cohete ni en la nave, por supuesto, porque se para todo completamente y se dedica todo este tiempo a la extracción de los astronautas. Una vez que estén ya fuera de la plataforma y obviamente lo suficientemente alejados del centro de lanzamiento, de la plataforma de lanzamiento 41 en Cabo Cañaveral, pues los técnicos de lanzamiento y demás continúan con la extracción del combustible. O sea, obviamente hay que vaciar todos los tanques de combustible de este cohete, llevarlo a un estado de seguridad atendible, y entonces ahí podrán empezar a maniobrar, a preguntar a todos los elementos tecnológicos y electrónicos involucrados en el lanzamiento qué fue lo que pasó. Por ahora no saben, o al menos no nos lo cuentan. Esperemos que nos lo cuenten pronto. Si todo estuviera bien, mañana a las 12 del día Eastern Time, hora de la Florida, estaría haciéndose el lanzamiento. Más o menos la misma hora que hoy, es la misma ventana de lanzamiento. Entonces, sobre las 5, 6 de la tarde, hora continental europea, estaríamos viendo el lanzamiento de Starliner, el primer lanzamiento tripulado, si es que finalmente puede ocurrir. Esperemos que sí. Estamos esperando todo el tiempo que sí. estamos confiando siempre en Boeing, en ULA, en que el próximo lanzamiento sí va a salir bien. Hasta ahora no cumplen con completa limpieza, pero esperemos que mañana pueda ser. También porque queremos hacer el lanzamiento, seguir el lanzamiento aquí desde técnicamente, y que bueno, que nos acompañen. Les pedimos entonces que estén aquí cerca, que se conecten con nosotros y así podemos seguir el lanzamiento juntos.
Into the spacecraft, keep that a very clean environment. So they'll have that sealed up here shortly, and then we'll start to see them
open the hatch to Starliner.
One of the benefits, one of the silver, because we can call it silver lining from the previous launch scrub, is that all the teams are able to take a moment now and study the data from what was essentially a wet dress that got down to just under 4 minutes. The launch team will do this. They'll look at the data, they'll study and see how everything responded. Starliner and the Boeing team will do the same thing. And of course, on the May 6th attempt, that's when they discovered the helium leak, and then studied that issue for a number of days and came up with a plan to make sure that was accounted for should the Boeing Starliner go to the International Space Station and then need to deorbit. So in this situation, there will also be a benefit to looking at this data, Dylan, and I wonder, as a launch conductor, you've been involved in a number of those as well.
That's true, and really, we're just going to keep the team focused on the tasks ahead of us, and right now that is the most important thing. So we're focused on supporting the blue team, the team on the pad, as they get the white room configured and prepare to egress Suni and Butch, and then we'll move on to the next step, and we'll proceed methodically.
Finalmente el vuelo de la Starliner ha sido suspendido completamente, o sea, hasta mañana no se tendrá noticia, hasta para un lanzamiento hasta el mediodía más o menos. Así que bueno, no hay mucho más que hacer por hoy. Ellos ya se están ocupando de sacar a los astronautas de la nave Starliner. El equipo de plataforma A está trabajando en eso, de manera que los extraigan completamente seguros y sin que ocurra ningún accidente. Esto está bastante controlado en tierra, así que no debe haber ningún problema. Así queremos que se desarrolle. Y bueno, si hay lanzamiento mañana, nos vemos aquí en Técnicamente. Espero de verdad que nos acompañen. Quienes estén a mano, acérquense. Aquí les podemos contar muchos de los detalles que tienen que ver con el lanzamiento, de las cosas que ocurren cuando un lanzamiento como este, tan importante y que involucra astronautas, ocurre. Así que bueno, si tienen dudas, vengan, pregunten, aparezcan por aquí, ayúdenos a seguir creciendo en Técnicamente, y como se va volviendo un lema de nuestros vídeos y nuestras transmisiones, acercar juntos el cosmos a nuestras vidas. Nos vemos mañana si hay lanzamiento. Ojalá ya estén por aquí. Muchas gracias a los que pasaron y a los que vengan mañana también.
Happened at 12:21 p.m. Eastern Time. We were counting down towards a 12:25 p.m. launch when the ground launch sequencer issued an abort command that stopped the launch of the Atlas V rocket and Boeing Starliner spacecraft. The reason that this ground computer called it is not known at this time, though ULA is looking at the data and studying that. Immediately afterwards, the ULA team began to what's called safe the rocket, essentially making sure that all of those high energy systems are put into a configuration that is safe for people to be out there on the pad and for the astronauts, Butch Willmore and Suni Williams, to come out of the capsule and head back